let's review the rules for multiplying and dividing signed numbers so that we can look at some situations where sometimes students have difficulties. Remember that to multiply or divide signed numbers, if the signs are alike, the answer is positive, but if the signs are different, the answer is negative. Now, let me remind you also of the rules for adding signed numbers. I want to just speak to one rule that is often confused with this one. Remember, when you're multiplying signed numbers, if the signs are alike, the answer is positive. So if I multiply two negatives, the answer is positive. But remember, when you add two negatives, the answer is negative, because when you're adding, if the signs are alike, you add and keep the same sign. So students often get these rules confused. So when you're multiplying two negatives, the answer is positive. But when you're adding two negatives, the answer is negative. So please remember that. Now, let's suppose I ask you to simplify this expression. Please recognize that this is a multiplication problem because there's no symbol between the parentheses, so we automatically understand that it's multiplication. Now, there are four numbers there. You can only multiply two numbers at a time, so you can multiply the -1 times the -3, take that answer, multiply times 2, take that answer, multiply times -5. However, it's so much easier when you have to multiply several numbers. Just as when we were adding several numbers, we kind of had a shortcut. If you're multiplying several numbers, it's easier to look at the problem and decide whether the answer is going to be negative or positive to begin with. Then when you start to multiply, you can forget about the signs. Okay? So in order to decide whether the answer is going to be negative or positive, simply count. This is a shortcut for finding the sign of the answer. Simply count the number of negatives. Now, it doesn't matter how many positives there are. Simply count the number of negatives. I see there are 1, 2, 3 negative signs here. Therefore, I know the answer is going to be negative. Now I can just multiply the numbers. 1 times 3 is 3, 3 times 2 is 6, 6 times 5 is 30. And you may say, well, how did you know the answer was going to be negative? Because if you just count the number of negative signs, if there's an even number of negative signs, the answer is always going to be positive. But if there's an odd number of negative signs, the answer is going to be negative. Now, this is not a rule for addition. This is for multiplication. So if I have to multiply several numbers, I can just count the negatives and determine whether the answer is going to be positive or negative, so I can get my sign first. Then I can just multiply the numbers to get the numerical part of the answer. So here, notice I'm multiplying. This is a multiplication problem. I'm multiplying three numbers. Notice two of them are negative. 2 is an even number. Therefore, I know the answer is going to be positive. Now, since the answer is positive, I can put the sign or I can not put it. At any rate, now I can just forget about the sign and multiply 13 times 2 times 3. Now, notice this is not a multiplication problem. This is an addition problem, but there's something different about this addition problem. Notice that the plus has been written in. Now, we're not accustomed to that. We hopefully do not want to see those pluses written in, so please realize that 4 plus -3 should be written like this. We should just be thinking the plus. Another way to think about this problem is to realize that this problem is really two problems in one. After the plus, I can put a 1 times. This problem is really 4 plus 1 times -3. And of course, according to the order of operations, you would multiply before you would add. So 1 times -3, the signs are different, so the answer is negative. Now, another shortcut for thinking about this is anytime you see a number that has two signs in front of it, just count the negatives. Just use that multiplication rule. Count the negatives. Since there's one negative and one is an odd number, you can replace both of these signs with a minus. So looking at this problem, I know the 5 is negative, so I can just bring it down. But is the 3 positive or negative? Well, it's preceded by one negative, which is an odd number, so I can replace it with a negative. And now the signs are alike, so I can add and keep the same sign. But notice here, even though the 8 is positive because there's no sign in front of it, the 5 has 2 signs in front of it. They're both negative, so there are 2 negatives. 2 is an even number, so I can replace both of those with a plus. So now the problem is just 8 plus 5. So I am saying do not attempt to simplify an addition problem if there is a number that has more than one sign in front of it. First of all, get rid of the double signs or get rid of the more than one sign. Replace it with one sign by using your even-odd rule, and then find the answer. So here I'm going to replace the 2 negatives with a plus. Now the signs are different, so I'm going to subtract and use the sign of the one further from 0. So to give an extreme example, I can look at this problem and I can see that the 7 has no sign in front of it, so I know the 7 is positive. But the 3 has many, many signs in front of it. So is the 3 positive or negative? Well, the easiest way to determine that is to just count the negatives. Notice there are 5 negatives in front of the 3. Now, if there had been a negative in front of the 7, I would not have counted it. I only count the ones in front of the 3, between the 3 and the 7. There are 5 negatives. 5 is an odd number, so I replace all of those signs with a minus. And now I'm going to say 7 plus negative 3. The signs are different, so I'm going to subtract and use the sign of the one further from 0. So we need to discuss how do you read a negative. Now, if you have a negative in front of a number, we usually just say, as in this case, this is negative 4. But if you have a negative sign in front of a variable, it can be confusing to read it as negative x, because if negative x makes it sound as if the value is negative. Now, if x is 3, and I have this negative sign in front of it, it is a negative 3. But let's write that negative sign, and now in place of x, let's put negative 3. Now it would say a negative 3, which is a positive 3. So if you read this as negative x, it makes it sound as if it's a negative value when it may or may not be. So it's really better to read this expression as the opposite of x. So we read the negative as the opposite of. Also, you can think of that negative. You can put in a 1 times after that sign and think of it as negative 1 times x. So the opposite of x is the same as just multiplying x by negative 1. Now, you have probably learned in the past that a number that's multiplied by a variable, that the number in front of the variable is called the coefficient of the variable. So here the coefficient of x is negative 1. Now, in talking about negative 4, we could also say the same. I could read this as the opposite of 4, or negative 1 times 4. But most often it's easiest to just say negative 4. But when we look at this expression, it's really best to think of it as the opposite of x, or negative 1 times x. Let's look at some examples. So here are 2 examples where sometimes students get confused. So let's read this expression. Now notice the expression has parentheses. So I read this as negative 5 quantity squared, or negative 5, the quantity, negative 5, taken to the second power, which means negative 5 times negative 5. In other words, the exponent applies to what's immediately in front of it, which is the parentheses. So that means the parentheses has to be repeated. So a negative 5 times a negative 5 is a positive 25. But now look at this expression to the left. Notice there are no parentheses. If we think of this as the opposite of 5 squared, then we all know that 5 squared is 25, and the opposite of 25 would be negative 25. Another way to think of it is to put in a little negative, to put in a 1 times, is to think of this as negative 1 times 5 squared. And according to the order of operations then, we're going to do the exponent first, and then we multiply, either way you get negative 25. Now, another way to see this is, remember when you were doing the order of operations, before we even talked about negative numbers, if I gave you a problem like this, you would look and you would say, oh, there's subtraction and there's an exponent. And so you would say, oh, I need to do the exponent first, so you would bring down the 30 minus, and then instead of bringing down the 5 squared, you would bring down the 25, and then you would subtract. So notice that even here, this shows that the opposite of 5 squared is negative 25. So let's look at this example. How can I read this example? I can read this as the opposite of b, quantity cubed. Now, that sounds kind of confusing, so all I need to do here is to say, well, I know that b cubed is going to be a b to the third power, and then I just need to decide how many negatives do I have multiplied here. So I can put in 1 times, and I can put in a 1 times. Now notice that this exponent applies to the parentheses, which means it applies to everything in the parentheses. So this exponent of 3 is telling me that the 3 applies to the negative. So there's actually 3 negatives here. There's another one here. 3 plus 1 is 4. 4 negatives. 4 is an even number. That tells me that the answer is going to have a positive symbol. However, here, notice the exponents are inside the parentheses. So here the 4 only applies to the b. The 3 only applies to the b. The 2 only applies to the b. So how many negative signs do we have? Just 3. 3 is an odd number, so I know my answer is going to have a negative sign. And of course, remember, when you multiply like bases, you add the exponents. So 4 plus 3 plus 2 is 9. Looking at this expression, if we want to simplify it, I can count the negatives. 1, 2, 3, 4. 4 negatives. 4 is an even number, so I'm going to replace all of those with a plus. So I know the final answer is going to be positive. Now I'm ready to just multiply the numbers. Since the last number is a fraction, let's make them all a fraction. And now let's cancel if we can, multiply straight across, and of course the answer is positive.